Good morning all. This is Sadesh Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on Discrete Fourier Transform. That is nothing but decimation in frequency, Fast Fourier Transform. What is meant by Fast Fourier Transform? Fast Fourier Transform is a family of algorithms that calculates efficiently the discrete Fourier transform. The DFT is also a sequence x of k. The efficiency of FFT is at the maximum when the length of the sequence is a power of 2. That is, n is equal to 2 per p is a positive integer. The complexity of FFT algorithms is order of n into log 2 of n. Now we can fast Fourier transform from the time domain sequence that can be converted into frequency domain sequence. See, splitting operation is done on DIT FFT method. Frequency splitting operation is done on frequency domain basis in DIF FFT method. Now we can going to calculate from time domain to frequency domain with the help of fast Fourier transform. List the methods of FFT is nothing but DIT FFT, DIF FFT, decimation in time, fast Fourier transform, decimation in frequency, fast Fourier transform. This is the Radix-2 DIT and DIF FFT. DIT is nothing but B, capital A is equal to A plus B into Wn power R. B is equal to A minus B into Wn power R. In DIF is nothing but A is equal to A plus B. B is equal to A minus B into Wn power R. This is the input sequence order, original form 0 to 7. The binary of representation of 0 to 7 can be also be given 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Reversed form also, bit reversed order can be also be given 0, 4, 2, 6, 1, 5, 3, 7. The bit reversed order binary representation can be also be given in terms of reversed form. Next one, complex multiplications. Each inner product required n complex multiplications. There are n inner products required n square multiplications. Therefore, there are 2n minus 1 such instances. Therefore, number of complex multiplication is n square minus 2n plus 1, that is n minus 1 the whole square. Complex addition means each inner product required n minus 1 complex additions. There are n inner products required n into n minus 1 complex additions. Therefore, number of complex multiplications is n minus 1 the whole square. Number of complex addition is nothing but n into n minus 1. This is the 4-point DIF FFT is nothing but the input must be in your normal order. The output must be in your bit reversed order. This is the 4-point flow graph of decimation in frequency FFT. The output must be from the results of 4-point DFT. We can going to compute 2-point DFT. Finally, the output must be in your bit reversed order. Given x of n is equal to 1, 2, 3, 4, find x of k using 4-point DIF FFT algorithm. X of 0 is equal to 1, 1 is equal to 2, 2 is equal to 3, 3 is equal to 4. We can get the output as 1 plus 3, 4, 2 plus 4, 6, then in 1 minus 3 which is equal to minus 2, 1 minus 4 is equal to minus 2. We can get the output as 4, 6 minus 2 minus 2. From the results of these we can going to compute 2-point DFT. From the 10 minus 2 plus 2j minus 2 minus 2j. Therefore, the output must be in your bit reversed order. Therefore, normal order x of k is equal to 10, minus 2 plus 2j minus 2, minus 2 minus 2j. This is the decimation in frequency FFT. Now, this is the 8-point decimation in frequency FFT. The input must be in your normal order. First, we can going to compute 8-point DFT. From the results of 8-point DFT, we can going to compute 2 4-point DFTs. From the results of 4-point DFTs, we can going to compute 4 2-point DFTs. Finally, the output must be in your bit reversed order. We can get take your answer as your normal order. Find the 8-point DFT of the sequence x of n is equal to 2, 1, 2, 1 using DIF FFT algorithm. 2, 1, 2, 1, remaining all others are 0. We can get the output sequences 2, 1, 2, 1, 2, minus 0.707 minus j into 0.707 minus 2j minus 0.707 minus j into 0.707. From the results of these two 8-point DFT, we can going to compute two 4-point DFTs. The output must be in your 4200, 2 minus 2j minus j into 1.414, 2 plus 2j minus j into 1.414. From the results of these 4-point DFT, we can going to calculate 2-point DFT. 6200, 2 minus j into 3.414, 2 minus j into 0.586, 2 plus j into 0.586, 2 plus j into 3.414. This is the output sequence. Now we can going to see the difference between DIT and DIF FFT. Decimation in time is nothing but DIT FFT algorithms are based upon decomposition of input sequences into smaller and smaller subsequences. DIF algorithms is based on decomposition of output sequences into smaller and smaller subsequences. The input sequence is split into even and odd number of samples. The output sequence is split into even and odd number samples. Splitting operation is done on time domain sequence. Splitting operation is done on frequency domain sequence in DIF. In DIT, the input must be in your bit reversed order. The output must be in your normal order. In DIF, the input sequence is in normal order. The output sequence must be in your bit reversed order. The fast Fourier transform is widely used in signal processing applications, spectrum analysis, coding, etc. Spectrum analysis is used for analyzing and detecting signals. In coding, audio and speech processing signals coded in frequency domain using FFT variants, that is MP3, etc. Recent application is modulation scheme called digital radio audio broadcasting. Noise reduction for mobile telephony, speech and audio signals is implemented in the frequency domain using FFTs. Now we can see the assessment. Define fast Fourier transform. Fast Fourier transform is a method of algorithm that can use it to compute with less number of computations. In DIF, input sequence must be in your normal order. The output sequence must be in your bit reversed order. Define Radix-2 DIF FFT when we giving as A and B, where capital A is equal to A plus B, small capital B is equal to A minus B into Wn per R. List the applications of FFT. It is used in digital processing signal applications. It is used in coding signals. It is used in spectrum analysis, etc. Determine DIF of x of n is equal to 1, 2, 3, 4, which is equal to, which can produce the output sequence x of k is equal to 10, minus 2 plus 2j, therefore which is equal to minus 2, minus 2, minus 2j. What is the difference between DIT and DIF FFT? Decimation in time. Splitting operation is done on time domain sequence in DIT. In DIF, splitting operation is done on frequency domain sequences. In DIT, the input must be in your bit reversed order, output must be in your normal order. In DIF, the input must be in your normal order, the output must be in your bit reversed order. Thank you.